Hello, and thanks for watching this week. We're continuing with our discussion, like I promised, around wedges, which are simple machines, and we're going to transition into some other learnings today. Hopefully it'll make you a better rounded citizen, more independent person long term, not necessarily an aerospace technician or anything like that, but some general knowledge will help you through life. Anyways, May 26, 2020, hope you had a good Memorial weekend. Here's the engineering tech notebook page, which is the same as ManTech and aerospace. And here I have it all laid out for you. Watch the video. You can look at the PowerPoint at the same time. And then you're going to watch two more short videos, one on a bottle jack, because that has to do with car maintenance. And most of you might use those if you work on your own cars. So what that looks like, and then the science behind a bottle jack, 1.5-minute video on what that looks like. And then 3 questions I'd like you to email me. And then aerospace, you have one continued work through your competencies worksheet. That's on your class notebook. If you need help with that, let me know, but really need you to get going on that because it's going to play a big factor in your certificate because we've been away not working on the skills. So please watch this video link here. If you're new to it, it'll show you where everything is and how to start filling it out. Email me with questions. All right, jumping over to our PowerPoint this week. Continued on with simple machines. Here's our goals from last time. And then here's our goals this week. And as you can see, we're still not looking at the math. I'm just going to talk about the math a little bit more, but I'm not giving you the worksheet to go through anything. Not trying to overwhelm you with math. If you're not good at fractions and algebra, we're just trying to learn basic physics behind some of our simple machines and how they can function in life and how they can help us. So going to look at wedges. I think it's only 3 or 4 slides long. Talk about the mechanical advantage along with that. And then we're going to get back into some previous learning from a couple weeks ago, car lifts, like a bottle jack, because some of you might have seen that, and I just put mine in my emergency kit as I reorganized my car this week. And then we're going to look at how it could help you. A hydraulic system could help you more so in a log splitter, and make sure you understand that. Go split some wood if you need to split some wood and get it seasoned, or go ahead and shop for a log splitter and then answer a few questions. So here's what we're looking at, the wedge. Last week we talked about inclined plane and the screw, because the screw jack was something we saw in our emergency car kits. And then that's why we're still talking about the bottle jack, is because it fits into our emergency car kit learning. So wedge, you can see splitting wood, firefighting. Basically, we're trying to get a mechanical advantage. So we're going to look at some forces. Basically, again, we're going to compare apples to apples, oranges to oranges. So making sure we only compare somebody's height to another height of person. Can compare somebody's body weight to somebody else's body weight. We wouldn't compare body weight of one person to the height of another person. Those aren't consistent variables. And so that's really what we're doing, just trying to focus on ratios with mechanical advantage, and that was talked about last week. So going to fast forward here. Again, we didn't focus too much on that, but this is what I'm talking about. We're going to look at the distance traveled in this one for ideal mechanical advantage. This is a theory-based system, so we're not taking into account friction. And so the DE and the DR, as you can see at the bottom, are just the distances traveled by the effort force and the resistance force. And then we're actually accounting for friction. So then we're looking at the resistance and effort forces, the actual magnitude of them. Okay, skipping the inclined plane, we're focusing on wedges. Okay, so wedges, the function is a moving inclined plane. So as you can see, if we were driving this wedge downward into the block of wood, which the force is a down red arrow going into a red wedge, it should force and separate the material outward, and then those two forces should also equal the magnitude force. So we're going to look at that on the next page. But this is really helpful for lifting larger bodies, like the PowerPoint says. Splitting things is really hard work to split rounds of a tree for firewood, so that's why we're going to look at the log splitters. And then we can also implement a screw jack to help with this wedge. So instead of hammering behind it, we could have a screw that would be driving the wedge in. That would be a combination. So we can do a lot of different things with a little less effort on the human body by just being smarter. Okay, so here's a wedge. Basically, it's a triangle. It's a 10-inch long triangle. The height, these are a little funky how they label them, but we're going to keep with it. Height is 3 inches. And then ideal mechanical advantage, IMA, is going to be the distance of the effort over the distance of the resistance. And so the effort is what is the downforce. So that's how 10 is associated, how it says that equals L and L equals 10. And then H is the distance traveled for like the block of wood to separate something. So that would be the horizontal measurement of 3 inches. So this is our formula we'd be using. Simple. We just plugged in additional information about the variables DE and DR. So the IMA of the wedge at the right, if we're looking perpendicular to the height, then that should be 10 on the top, I believe. And then we should have H on the bottom, which is 3. So 10 divided by 3 should get around to 3.3. So that can give us basically an advantage of 3.3 times the effort we put into it. So if we think about how much effort as a human we're putting behind that sledgehammer to drive this in, we're actually going to get out 3.3 times more of the effort we put in just by simply making a physical device to help us through that. So kind of cool. This is going through the same thing. So this is looking more at the actual. So this is factoring in friction. And so actual mechanical advantage is AMA. And so now we're looking at the forces, 250 and the 700. And so if we're factoring in friction, heat loss, things of that nature, rubbing, all those things, coefficients of materials, which you'll get into college, you're going to look more at a little bit less. So 2.8 is more the realistic one. And then we could always factor in efficiency. I didn't talk about this last week. All it is you have to find the AMA and the IMA together. And so efficiency is just basically looking at the theory base versus the actual one and how much percentage loss you get there. And then if you use the equation below and multiply it by 100, then we basically get our efficiency, which is 84, which is still great and better than a lot of things. And then we would just use this math to design mechanical systems, cars, different things, and try and figure out gas mileage and figure out the best way things mesh together and work together. So, talked about the screw last week. Okay, thank you for watching a little bit on wedges. So basically a wedge really helps drive a piece of wood and split a piece of wood. But now we're going to move on to, since we're on the topic of wood splitting, and that takes a wedge, that got me thinking of log splitting because I've already split my firewood and I've started rotating firewood to season it to dry it out. So what I want you all to kind of think about is why I'm going off on this tangent from wedges to hydraulic splitters back to the car splitter. I'm trying to wrap up last week's learning with the car hydraulic jack, bottle jack as they're known, the one on my screen in blue right now, and then also relate it to splitting wood. So trying to kind of wrap up both topics with multiple learnings here. So go ahead. The link is at your class notebook, so it'll bring you up to this one. Watch this 2.5 minute video, and then this 1 minute 20 minute video, minute 20 video goes through what is actually happening internally to give you that mechanical advantage. And then the next thing I want you to do is do a little bit of shopping. So basically I'm asking you to look up a log splitter, and the ones I found were kind of interesting because log splitters, we have these manual ones for $100, but these gas-powered ones, log splitters that use a hydraulic system, can be anywhere from $600 to $1,000. So I was going to have you shop around for these ones. Here's a good one, a kindling splitter. This is a good welding project you can do if you're going to be with me next year in the shop. I have some plans on that. But anyways, I want you to shop around for a log splitter. Maybe you are somebody that enjoys wood warmth and the smell of it. Maybe you aren't, but it's a good way to make some money, mow the yard, and then also split some firewood and sell things that way. And then aerospace, don't forget to email me. Aerospace, make sure you check out your competencies page and this video. Thanks for watching, everybody. Have a fantastic day.